Here's a solution to one of the area problems from section 4.4. In general, when we're trying to find area between curves, we said that the limits of integration are the starting and ending values of the interval of x for which things over. In other words, we want the lowest x value at the bottom and the highest x value at the top in our region. And then we want to take the formula for the top curve, and subtract the formula for the bottom curve. And the idea behind that, remember, is that the formulas for the curves describe y-coordinates. So if I were to draw a little rectangle in here, the idea is that the y-coordinate of the top curve minus the y-coordinate of the bottom curve describes the height of that rectangle. And so this part of the formula, the top minus bottom part, that is the height of a rectangle. The dx is a very, very small change in x, so that represents the width of the rectangle. And so, so this times this is height times width, so that's the area of a rectangle. And that rectangle can be drawn for any value of x that starts at -2 and ends at 3. So the first value of x you could do this for would be -2, and the last value of x you could do it for is 3. And so that tells you what these values are. So you don't have to draw a rectangle or do that stuff, but I'm just explaining why this is the correct formula. So all we have to do is know where the lowest x value and the highest x value are, and then know which formula is the top curve and which formula is for the bottom curve. And so since we have the picture here, a lot of that has already been figured out for us. So we're going to want to have the integral from -2 to 3. And again, without a picture, we would have had to set these two things equal to each other and try to solve for x, which would have been no fun at all. So it's a good thing they gave us that. So from -2 to 3, we want the top curve, which is -19x plus 138, minus the bottom curve, which is x to the 4th minus 8x cubed minus 24x squared dx. So that's the integral. It looks awful. But let me just tell you the antiderivative to make sure that part's right, and then we'll make sure we're sticking the numbers in right. I would probably simplify that because it's already going to have enough parentheses as it is, so I would resolve this minus parentheses thing here. So let me do that, and let me also write the terms in sort of order in the order of degrees of x's, because that's a lot easier to look at. So this is just a rewrite so that I have a better looking answer. So I'm going to write that first part as 138 minus 19x, so that I have the things with the increasing degrees of x's, plus 24x squared. Again, I'm just doing looking at the minus here, plus 8x cubed minus x to the 4th. And so that's a little bit easier to look at. And so I need to find the antiderivative of that. And I'm going to evaluate that antiderivative from -2 to 3. So the antiderivative here will be, well, 138x. I'll have 19 halves x squared. I'll have 8x cubed. I'll have 2x to the 4th. And I'll have 1/5 x to the 5th. So that's my antiderivative. It's very easy, again, to just take a second and think about what the derivative of what I just wrote down would be. It's easy to see that the derivative of that is that, right? Because my derivative rules are more familiar. So it's very easy to check that I really did get the right thing. This paren is supposed to be out here. I didn't quite squeeze it all in there. That 5th power is not outside the parentheses. My parentheses are just too close. Okay. And so now I have to plug in 3 and plug in -2. And so that can be a challenge. Plug in 3 and then minus plugging in -2. But again, keeping parentheses on here is really going to be the key. I would leave the fractions as fractions. So let me just get my calculator out here. Okay, so plugging the numbers in, when I put 3 in for x, I'll have 138 times 3, which is 414. 19 halves times 3 squared. 19 times 3 squared is 171. 8 times 3 cubed, that's 8 times 27, that's 216. 2 times 3 to the 4th is 162. Let me just straighten up that 2. Yeah. So that'll be 2, and then 3 to the 5th power is 343, so, or 243, so I'll have minus 243 fifths. And again, all of that is in parens. And then what I'm subtracting is what's going to happen when I put negative 2 in for x. So I'll have 138 times negative 2, which is negative 276. I'll have 19 halves times 2 squared, negative 2 squared, so that's 19 halves times 4. It's 38. I'll have 8 times negative 2 cubed, so that's negative 64. I'll have 2 times negative 2 to the 4th, which is positive 32. And then I'll have minus 1/5 times negative 32, so plus 32 fifths. And again, all of that is in parentheses as well. So as I'm doing my subtraction now, I can just combine terms. It would be easiest to go ahead and add these whole numbers together and these whole numbers together. And then all I have to do is combine these fifths. So negative 243 fifths minus 32 fifths is going to be negative 275 fifths, and so that's actually a whole number. So the final answer is not going to have fifths in it, because negative 243 fifths minus 32 fifths is also a whole number. So it'll be something with halves in it because of that number right there. With my parentheses on it, you should try to see if you can calculate those numbers, and I can tell you that the final answer here is 875 halves. So try doing the arithmetic these last stages. Notice how I'm trying to put the numbers in one at a time, but then writing them down in my parentheses. Now I get my calculator out again, and I would try to combine these terms. The hard thing to do on a calculator is to string all of this together in one on one line, because this is going to wrap around several lines on most calculators. So do it in phases. Be careful putting the numbers in. You should be able to get it.